So this first one, we're dealing with directions, so let's remember north, south, east, and west. So the position vector of a ship, so let's say this is, we'll just put this on a grid here. Oops, let's see if I can make that grid nicer. So that first ship, 30 kilometers north and 60 kilometers east. So it's right here, so that's 30 and 60 east. And our other ship, 20 kilometers north and 45 east. So it's asking us what is the position of the ship relative to the buoy. So how far away are these? Well, let's see, 60 and 45, so we got to go over 15 and 10 north. So it's 10 degrees north and 15 degrees east. What is the exact position from the ship to the buoy? Well, we know if we were to write it in vector form, it would be 10 and 15. Or excuse me, vector form. We write the x on top, so 15 and 10. So we'd have to do 15 squared plus 10 squared, and then we would take the square root of it. And you would need a calculator for that. The particle moves with constant velocity and arrives at the point Q 4 seconds later. So find the velocity of P. Well, this is moving in 4 seconds. So if I divide each of these by 4, in 1 second, it's moving at 5, -2. And then we talked about the velocity is, we have to do the Pythagorean theorem, the magnitude, so 5 squared plus -2 squared. So we have the velocity is the square root of 20. Continues to move at the same velocity for 6 more seconds. So, well, one thing I notice, if it's 28 and 4 seconds, then it'd move half of that in 2 seconds, so 10 and -4. And then if we add those together, it'd be at 30, -12 seconds, because this would have been 2 seconds. But we have to add it to the original, because we need a total of 10 seconds, so we have to have another 4 seconds on there. So we have to add the 20 and -8, because this is 6 seconds now, and this would be another 4 seconds. Because we have to have a total of 10, because 6 more, so our total is 10. So we have 50 and -20. Of 12i plus 5j, it passes through a point 4i minus j. So I'm going to write the equation for this. So it's starting at 4, -1. Plus t, and the velocity would be 12, -5. So the speed, once again, we have to do the Pythagorean theorem with our directional vector. So 12 squared plus -5 squared. Then we have to take the square root of that. And I think that turns out to be 13. So it's moving at 13 meters per second. So find the distance from O when t equals 3. So let's see. It starts here at 4, -1. Where is it when t equals 3? So 4, -1 plus 3 times 12, -5. So we have 4, -1 plus 36 and -15. So that equals 40 and -16. So that's how far away it is. And it starts at 4, -1. So 4, -1, and then it goes to 40, -16. So how far did it really travel? Well, the difference between that, it goes up 36 and down 15. And then we have to find that distance, so we have to do the magnitude again. And see what you get there. About here. It's actually talking about this top particle that starts at the origin. So it's saying like we have these two equations. So we have r equals, what was it traveling each second? 5, -2 each second. Whoops, that didn't turn out. So r equals t times 5 negative 2. And then we have our other line. So we have the second one, particle, 4 negative 1 plus t times 12 negative 5. So we have to find out if the particles will collide. Alright, so what is our x? Is 5t equals 4 plus 12t. And then our y, negative 2t equals negative 1 minus 5t. So if we solve a system, I'm going to make the t's the opposite. So times 2, and this one times negative 5. So we have 10t equals 4 plus 24t. And then we'd have negative 10t equals, that'd be negative 5 minus 25t. Add these together, 0 equals negative 1 minus 1t. So let's see if I add t, so 1t equals negative 1. So we have t equals negative 1. Something seems a little off here. I'm trying to figure out where we went wrong. So let me try this again. 0 plus 7x, 3 plus 2t, 6 plus 3x, 1 plus 4t, plus 1s, 2 minus 1t. So we're going to make this opposite so the top stays the same. Multiply by negative 2. Negative 2 times negative 1 is 2. Negative 2 times 1s, negative 2x. Negative 2 times 2 is negative 4. Oh, I know why. This doesn't need to be, it's already negative, so I should just multiply by 2. So if we multiply by 2, we have negative 2 plus 2s equals 4 minus 2t. So now they're opposites. So negative 2 plus 9s equals 7. So now if we solve this, s equals 1. So then we can plug in that for s. So we have our first line equals 0, 6, negative 1, plus 1 times 7, 3, 1. So the times 1 doesn't change that, so we end up with 7, 9, and 0. So it intersects at the coordinate 7, 9, 0. Alright, in this next one here, find A, B, and AC. So A to B, negative 2 to 1, we go up 3. 4 to 7, we go up 3. A to C, negative 2 to negative 3, we go down 1. 4 to 2, we also go down 2. So then we're asked to multiply these together. So 3 times negative 1 plus 3 times negative 2. So that is negative 9. And now we're asked to show the cosine. So let's think of this as ABC. So we found A to B is 3, 3. Well, if we were to find the magnitude of that, so that would be 9 plus 9, 18. So we have the square root of 18. The magnitude of AC, so if we square those, 1 plus 4, square root of 5. So let's see what BC is. So B to C, 1 to negative 3, down 4, 7 to 2, down 5. So we'd have 16 and 25, so square root of 41. And all you have to do here is you have to use the law of cosines. So BAC, so we're finding this angle, so I'll start it out for us. So we'd start with root 41 squared equals root 18 squared plus root 5 squared minus 2 root 18 root 5, the cosine of, I'm just going to write a, and then you would solve it from there. And the very last one, find the angle. Okay, so let's see. So we have a vector. I'm going to start here. We go over 3 and up 5. And then we go over 2 and down 4. So we have to find the angle in between. So we have to find this angle. Well, I'm going to argue we can find this top angle by doing the inverse tangent of 5 over 3. And we could find that bottom angle by doing the inverse tangent of negative 4 over 2. And we could see what we come up with there. And then we would add those angles together.